Hi, I'm Balaji Chippada and welcome back to my YouTube channel. In the previous video, we have learned about what is Numpy and how do you create a Numpy array, what are the different data types of a Numpy array, and what are the indexing, slicing, copies, views, and a lot of other stuff which are all completely basic from scratch regarding Numpy. In this video, we will see how you can manipulate numbers, maybe do mathematical operations, how you can add, how you can subtract, how you can multiply, and a lot of other stuffs that you can do with NumPy in this video. So without any delay, let's get started. Let's start by importing NumPy, and how you can do it. Import NumPy as np, and if I execute this is executed and that is fine. Now let's create a NumPy array called a, in which I have elements 1, 2, 3, and 4, and I am printing a plus 1. Let's understand this in detail. So my array a equal to 1, 2, 3, and 4, right? And I am saying a plus 1. That means numpy array, what it will do is it will take this element and it will add to every individual element inside your array. So a plus 1 will become 1 plus 1 which is 2, 2 plus 1 which is 3, 3 plus 1 which is 4, 4 plus 1 which is 5. So when I say a plus 1, what it will do is it will do element-wise operation of your array and it will add this number to all elements of your array. And likewise, I have this operator as well. This is an exponential operator, a star star 2. That means for every element inside your array, square that number. So my a star star 2 output would be 1 power 2, 2 power 2, 3 power 2, and 4 power 2, which would be 1, 4, 9, and 16. So this a star star 2 will return this, and I have one more function called square root, and we cite as sqrt of a. So what it will do is it will get square root of every element inside my array. Square root of 3 and square root of 4, and square root of 1 is 1, square root of 4 is 2, and square root of 2 is 1.41, and square root of 3 is 1.73. So this would be the output of a square root of function a. Hopefully that is clear. Now let's execute all of these and confirm the outputs. So I have 2, 3, 4, and 5. And when I say a star star 2, I get 1, 4, 9, and 16. And when I say np dot square root of a, I get this one. So you don't need to do a lot of manipulations to find a square root, right? You can just call this square root function and it will be doing it for you. And all of these are doing element-wise operations. Now let's print a. This is my a. And here I'm creating one more numpy array called b, and I'm creating by using a function called np once. So in the previous video we have learned about np.once, right? So what it will basically do is it will create an array of length 4, because this is the parameter as 4 and all the elements inside them are 1. Okay, and then I'm adding plus 1 to it. That means it will become 2, 2, 2, and 2. And my a is equal to 1, 2, 3, and 4. Now what I'm saying is print a minus b. That means element wise it will check 1 minus 2, that is minus 1, and 2 minus 2, that is 0, and 3 minus 2, which is 1, and 4 minus 2, which is 2. So my a minus b output would be minus 1, 0, 1, and 2. So if I execute this, I get this. Now I will print b as well. Print b, and if I execute this, I have 2, 2, 2, 2. Now if I do a star b, star is basically multiplication, and even multiplications it will do element wise. So if you notice here, 1 into 2, which is my 2, and 2 into 2, which is my 4, and 3 into 2, which is my 6, and 4 into 2, which is 8. So all of these are doing a element wise multiplications, addition, subtractions, everything. Now let's move on to a little bit complex one called matrix multiplication. Here I am creating a numpy matrix array which is of C, and I am saying using a function called np.diag 1, 2, 3, 4. So what happens in this scenario is here this will create an matrix like this, and the elements are as 1, 2, 3, and 4, because we are saying using a diagonal function, and remaining all the elements are zeros. 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is your C, right? Now what I'm saying is multiply C with another C. Hopefully you have learned about matrix multiplication, right? This is of size 4 by 4. It is a square matrix, and this is of size 4 by 4. And if I multiply both of them, I get an output which is of 4 by 4, right? And how do you multiply this? You get the first row and first column, and you say like this: 1 into 1, which is my 1, plus 0 into 0, 0, 0, 0. And then for the next record, this is your 4 by 4 matrix, let's assume. And for the next record, you do this and you take this and you multiply both of this and you get 0. And you take this and you take this and you multiply both of them, which is 0 and 0. Likewise, and for the second row, you take the second row from the first matrix and you get the first column of the second matrix and you multiply both of them and you get 0. And you get this one, and the next iteration you get this, and it will be 2 4, because 2 into 2 is 4, and 0 0, and then you get 0 0 9 0 0 0 0 16. So this is your output from C star C, which is basically your matrix multiplication. And in Numpy you can just say C dot C as well, C dot of C. This is basically doing a C star C only, but it is just another representation of doing the matrix multiplication. And I can execute this. So this is my C star C, 1 4 9 and 16. And if I do C dot C, I get the same output as 1 4 6 9 and 16. Hopefully that is clear. If you have any queries so far in this video, please let me know. And there are so many functions that are available in Numpy, guys. Like what I'm saying, like we have np.1s, np.0s, np.c.c, and we have all the logical operators. And I'm not going to cover all of them, but I'm going to cover which are mostly used in the industry. But if you want, you can just check this Numpy org documentation page. It has everything that you want, guys. And I'm not going to cover, and I cannot cover all of these in detail. You can just go through any of this and it will show you an example as well, and how to use one, what are the parameters that it will take, and all of that. You can just read the documentation and you can understand this. And if you face any problems while doing this, please let me know in the comment section below, and hopefully I will try to answer each and every one of you. Now let's talk about comparison operators. I have a numpy array A, which is np.array 1 2 3 4, and I have another array B, which is 5 2 2 4. So when I say A equal to B, what is happening in this scenario? It will check if 1 is equal to 5. If it is not, it will return false. And because 2 is equal to 2, it will return true. Now let's talk about element-wise comparison operators. I have two arrays in which A is 1, 2, 3, and 4, and B is 5, 2, 2, and 4. And I am checking for A equal to B. So what happens in this scenario is it will check element-wise whether the first element in A is equal to whether the first element in B. If it is equal, return true. If it is not, returning false. And then because 2 is equal to 2, I'm getting true, and 3 is not equal to 2, I'm getting false, and 4 is equal to 4, which is true. And this is what it returns when you say A equal to B. Okay, and when we say A greater than B, so it will check element wise whether 1 greater than 5. If it is not, it will return false. Whether 2 is greater than 2 or not, it is false, right? That is what is returning false. And whether 3 is greater than 2, yes it is, then it will return true. And 4 is not greater than 4, that is why it is returning false. And now we have array wise comparisons. Now we can say, what if you want to check whether both of these arrays are equal or not. So in this scenario, you can use a function called array underscore equal. So if I do this, because I'm passing A and B inside this function, and A and B are not same elements, same order wise, it is returning false. Okay, and if I say A comma C, and if I execute this, I get true because A is equal to C. Now let's talk about logical operators. So I have a numpy array A, and I am saying 1 1 0 0 and data type as bool. So what happens in this scenario if I do this and print A? So this is my array A. When I specifying the data type as bool, it will mark 1 as true and it will mark 0 as false. Okay, and when I take this, which is B, and if I execute this and print B, I get this is my B array. True, false, true, false. Now what I'm saying is np.logical or A B. So what happens in the scenario is it will check whether the first true and the first element in B, whether both are or not. If it is true or true, that means true, right? And true or false, it is returning true. And false or true, it is returning true. And false or false, it is going to return false. When both are false, it is going to return false. It is what OR operator will do, right? If you are not familiar with all of these operators, please watch my comparison operators video in Python. And if I do execute this, I get true, 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 and false. And I can even do logical AND as well, which will be the output as true, false, false, false. Hopefully that is clear. And you can do logical XOR, logical NOR, and a lot of other as well. And you can even do logical NOT. So what happens in case of NOT? So if I do this and if I say logical NOT, and because not will only take one parameter, which is array, and if I do this, it will opposite all the elements inside my original array into the returning ones. Because it is true, it is returning false, and it is true, it is returning false, and it is false, it is returning true. And now let's talk about mathematical operations as well. So I have np.arrange of 5, which is my a, and if I print a, I get this one: 0, 1, 2, 3, and 4. Now I'm saying np dot sign of a. So what happens in this scenario is, for each element of your array, it will compute sign of 0, sign of 1, sign of 2, sign of 3, and sign of 4. And if you remember sine theta and cos theta from trigonometry, this value is basically your theta, and whatever the value it returns, it will keep it inside an array. So sine of 0 is 0, sine 0 is 0, right? And sine 90 is 1. And if I get what is sine 1, it will calculate that, it will give you the output here. Okay, and let's execute this. It's an element wise operation as well. And if I do this, I get this one. Now what if I will show you an example: a equal to np dot array of 0 and 90, let's take it, and I will say np dot sign of a, and if I execute this, I get values at 0 and almost equal to 1, 0.89333. And I can do a log value as well for every element inside my a. What is the log value of it? Log of 0 is minus infinity, and log of 90 is basically 4.499. Hopefully that is clear. And I can just do like this, and I can give whatever the numpy array that I want inside this function. And I have my values minus infinity, 0, and all blah blah blah. And I can do exponential as well. What is exponential function? E power x. So when I say what is exponential of 1, that means e power 1. What is exponential of 2? That is e power 2. And e value is 2.71, something like that. And if I have to say exponential of a, which is 0, 1, 2, 3, and 4, it will calculate e power 0, e power 1, e power 2, e power 3, and e power 4. And e power 0 is equal to 1, e power 1 is 2.71 something, and e power 2 is basically square of this number, which is around 7.38. Likewise, it will do the element wise operations by using exponential function. And so far we have seen how you can add elements, right? Now how you whether can we add arrays of different shapes? Let's see that. If I execute this, this will throw an error called value error, because your array is of shape 0, 1, 2, and 3, and you are trying to add 1 and 2. So if I check element wise addition, so where am I going to add this 1 to? Whether I'm going to add this in the 0 index, 1 index, 2 index, or 3 index? It is not sure, right? And it is wrong as well. By doing additions of multiple dimensions, it is not going to do it. It is going to throw an error, value error. It is saying you are given a arrays of with different shapes, which is 4 and 2. It is saying a is of shape 4 comma 1, and 2 is of shape for this one, which is np.array 1 comma 2. Hopefully that is clear. And if I have to sort this out, then what I can do is I can give 0 and 0, and it will do element wise operation. See, cool. These are some important ones as well. Let's say I have my array np.array is equal to 1, 2, 3, and 4. And what if I want to do sum of all the elements inside my array? One possible thing I can do is I can do a for loop and calculate the sum by initializing some variable. So what I would do is sum equal to 0, sum equal to 0. For I in array, I will say sum plus equal to I, and I will say print sum. So this will give me this will give me sum of all the elements inside my array. But instead of doing this much, I can just do np.sum. This sum function will handle all of this for you. You don't need to write a logic for the same. Hopefully that is clear. And the sum of 4 plus 3 plus 2 plus 1 is 10, and I get the output as 10. Okay, now we have a two-dimensional array, and let's get this. So I have 1 and 1, and then 2 and 2. So this is a two-dimensional array. How you can find two-dimensional array? By looking at the number of closed square brackets. Now what I'm saying is x dot sum, I'm passing something called as axis. So let's understand what is this axis. Whenever it is saying axis as 0, that means it is basically to sum the elements in a column wise. If you see 1 and 2, these are on the same column, right? If I sum this, this will be 3, and if I sum this, this will be 3. So when I say axis equal to 0, that means it's a column wise operation. And when I say axis equal to 1, it's a row wise operation in arrays. Okay, if I say axis equal to 1, what it will do is it will sum both of these elements, which is 2, and it will sum both of these elements, which is 4, and it will return the output as 2 and 4. And here axis is equal to 0, it is returning output as 3 and 3. Hopefully that is clear. Make sure you remember this. Axis equal to 0, which is a column wise, axis equal to 1, which is a row wise array manipulation. What if I want to get the minimum of the array? Then I can just do x dot min of, and I can just call min function, and I have my array x. I'm saying 1, 3 and 2, and if I say x dot min, I get the minimum value. And if I want to get the maximum value, I can just do x dot max. Now this is important, which is Argmin and Argmax. Now here I have my array as 1, 2 and 3, and here in this I have this minimum and this is maximum, right? And if you remember the indexing, first element is indexed as 0, and second element is indexed as 1, and third element is indexed as 2. Now what if I want to get the index of the element which is the minimum element of my array? So I need to get 0 as an output as the index for the element which is the minimum inside my array. And how do you get it? By using a function called argmin. And if I want to get the max, you will say argmax. Okay, now let's execute this argmin. I'm getting 0 because the element 1 is at the index position 0. And if I do this, I will get as 1 because element 3 is at the index position 1. And now we have the logical operators np.all. So let's consider this as an array, and I have true, true and false. Whenever I say np.all, it will return true only if all the elements inside my array is true. And if I execute this, it will return false because one of the element is false here. And np.any, what it will do is it will return true if any one of the elements is true. Even though there are two false elements inside it, because of first element which is true, it is returning true. Okay, now I have this which is np.0 is 50 of 50. So what is this mean? np.0 is 50 of 50. We are creating a 50 by 50 matrix, 50 rows and 50 columns, and all the values inside it are zeros. That's what zeros function does, right? So inside this, what I'm saying is np.any a not equal to 0. That means it will check for each element. If it is not equal to 0, it will mark it as false. And if it is equal to 0, it will mark it as true. And if all the elements are zeros, it will mark every element as true. And because of doing np.any, it will return the value which is true or false. So let's execute this. Because a not equal to 0, all of them are returning false, it is going to return as false because all the elements are as zeros. And I can just say np.all a equal to a. I'm just checking whether two matrices are equal or not. And if both of these matrices are equal, then it will return true. If it is not, it will not return true. And you can check for any other matrix as well of the same dimensions. What if I create one more array b equal to np.array, and I will create for two elements 3 and 4. And if I execute this, this is my array. And if I say np.all, okay, sorry, I can do like this and it will create an array. And if I say np.all a is equal to b, it is going to throw you an error because you are trying to match the elements of an array which is of shape 50 50 by a shape 2. So you cannot do this. You have to define another array of same shape and you can just do this operation. Now let's take this complex example. I have ABC 3 arrays and the elements are 1 2 3 2, 2 2 3 2 and 6 4 4 5. Okay, first I am checking whether a less than or equal to b. It will check element wise res, and it will check 1 less than or equal to true. Because it is true, it is returning true. 2 less than or equal to true, true. 3 less than or equal to 3, true. 2 less than or equal to 2, true. And then I am checking b less than or equal to c. 2 less than or equal to 6, true. 2 less than or equal to 4, true. 3 less than or equal to 4, true. 2 less than or equal to 5, true. And I'm doing an AND operation. If both are true, it will return true, right? So because all of them are true, my AND operation will return true, 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 true. And I'm saying dot all. What it will do is if all of them are true, then it will return true. So by doing this, I'm going to get the output as true. See, we have done a lot of complex manipulation in a single line of code. That is the power of these operators. Hopefully that is clear. Now I have one more array called x. I have 1 2 3 1, and I have one more array which is two-dimensional array 1 2 3 and 5 6 1. Now I will print both of this. So print x and then print y. And what if I want to calculate my mean of x? So what is the mean of all the values inside x, which is 1.75, by using the function called mean. And I can get the median by using np.median. It is not x.median. And I get the value of this median, which is 1.5, which is the middle value. Okay. And what if I want to get the mean and median of the two-dimensional matrix? That is also important, right? So I have 1, 2, 3, and then 5, 6, and 1. Now here, because it is a two-dimensional array, I need to mention specify axis. Whether it is -1 or +1, it is going to do a row-wise operation. If it is axis equal to 0, that means it's a column-wise operation, and axis equal to 1, it's a row-wise operation. So I'm saying np.median axis equal to 1, that means you are saying row-wise operation. So median of 1, 2, 3, which is 2, and median of 5, 6, 1, which is my middle value, which is as 5. Hopefully you got that. And then we have standard deviation as well, and standard deviation is getting calculated over the whole data set or over the whole elements, and I get this, which is 0.829. That's all for this video, guys. We have covered a lot of element wise operations, logical operations, comparison operators, and we learned a lot of new concepts, right? And in the next video we will be taking a real life example by using a data set and how we can do manipulations on that data set. And we will also cover one more important topic called broadcasting, which is a very special property of arrays. Hopefully you learned something new from this video, and if you are liking the content, please do subscribe and click that bell icon to get notified daily. We'll meet in the next video. Bye bye.